All right, hello everybody. Good afternoon. Today we are starting unit number 4, which is called Matter and Change. Hello, Jackson. And we're going to get started with a thinking warm-up. So I did send the chat to the waiting room for those of you who got here early, but what we're going to be using is Menti. And so you can either go to menti.com and type in the number you see on your screen, which is 7710042, or you can just click the link that I put in the chat, okay? And so when you get to that screen, what you will see is, what do you think of when you hear the word temperature? We did something very similar on the first day of school. We did, what do you think of when you think of chemistry? But temperature is a very important vocabulary word. It's one that a lot of what we're going to do in this unit focuses on. So I just want to do a little brainstorm. What do you think of when you hear the word temperature? No right or wrong answer here yet. Just think real world. What have you learned about temperature in the past? And so right now we have 17 responses. Let's see how many we can get. Put as many things down, every word or phrase or topic or number or whatever that comes to your brain when you hear the word temperature. It can be anything related to this word. And we're going to take one more minute. What do you think of when we hear the word temperature? Let's see what you all thought. And this is a word cloud. Sean Paul again. Oh my goodness. My class yesterday thought Sean Paul as well, which if you don't know, Sean Paul does have a song called Temperature, which is a great song. It came out when I was like in middle school or high school, and it's a good song, so I'll take it. Okay, but we also have up here the bigger words were typed by more people. So the biggest words I see up here are weather, cold, heat, hot, which is good. I've seen those words in all of my classes. We also have heat, thermometer, warm, precipitation. Good. I'm actually glad you said that word. That has to do with weather. It's rain and snow, so very good. I also see Celsius and Fahrenheit right next to each other, which are going to be the two most common units used for measuring temperature. In the United States, we use Fahrenheit when talking about the weather on weather apps, like I see here, or on your thermostats. But United States is one of only 3 countries. We're the only major country in the world that uses Fahrenheit and the imperial unit system. I don't know why, but we do. The rest of the world, like 95% of the world's population, is actually going to use Celsius when talking about temperature. And so because we're scientists and scientists know no boundaries, we like to be able to communicate with scientists around the world. And so because of that, we use Celsius mostly when talking about temperature. But I do see it up here. There is a third unit that is used for temperature that we're going to learn about in this unit that's actually extremely important for chemistry. Does anybody know what that third unit for temperature is? It's on here, so at least one person knew. It is Kelvin. Very good, Naomi. Kelvin is a third temperature scale that we are going to learn where it came from, what makes it different. We'll learn about where all the temperature scales came from, but we'll mostly use Celsius and just a little bit, but then mostly we will be using, I have to sneeze and it's not working. We'll be using Kelvin, okay? I was holding it in for too long, but good. So I also see the sun, cool, water, degrees, weatherman, orange. I don't know why that's up there, but I'll take it. Rain, Miss Garcia. Hot or cold, thermostat, snowy mountains, snow, degrees, numbers, and Sean Paul and Pitbull, apparently. So good. Most people, when they go and somebody asks you what temperature, people will say something about this. Hot, cold, warm, weather has something to do with heat. But what if I told you that on this screen right now, there is not a single thing that is the correct definition of the word temperature?
Mercury.
Temperature is related to all of these things, of course, but none of these things define what temperature actually is. So my friends, I hate to break it to you. I know you've been told since elementary school that temperature measures how hot or how cold something is, but I'm here to reveal the truth. You have been lied to your whole lives. Temperature does not tell you how hot something is. Temperature does not tell you how cold something is. In fact, there's actually no such thing as cold. We'll learn about that later in this unit. But temperature is related to these things, but you have been lied to your whole lives. Temperature is not a measure of heat. It is not going to be how hot, how cold, how warm anything is. It is something different, okay? So Naomi, the absence of heat is what we infer as cold for the most part, but we're actually going to learn it's a little bit more than that. So yes, my friends, you have been lied to about what temperature actually is. Of course, it's related to heat, otherwise the world would just go up in smoke every time anybody took a Chemistry 101 class. It is related, and we are going to learn about how it's related to that later on in this unit. We're going to actually have a whole lesson devoted to temperature versus heat and talk about what makes them different and also what makes them related to each other. Okay? But I am not going to tell you the definition of temperature quite yet. You're going to hold that thought. You're going to fester with this idea that you've been lied to your whole lives. And we're going to talk about something else that's going to start to get us to start to understand what temperature is actually defined as. Okay? So what we're going to do now is we're going to do a breakout session. Here are our learning targets for the day. By the end of class, I can describe the different phases of matter based on particle behavior, and I can define temperature, okay? Hugo, we are not on Pear Deck today. We're going to be doing a breakout room session here in just a moment. I did have a Pear Deck exit ticket, but we're going to wait and do that on Thursday. So you're here, you're good to go, okay? So what we're going to do is a breakout room brainstorm. I am going to send you a link to this document here in just a second. I need to make sure that the settings are correct because they were not correct on my last class. To get to this document, and you're going to be assigned a random breakout room. Okay, that room is going to be your group slide. And so as you can see here on the example on my screen, it says group number 1. And what you're going to do when you get to this slide with your group, you're going to have 3 pictures of 3 substances. They're actually GIFs, whatever you want to call them. And you have 3 main focus questions. They're on the bottom of the screen. I'll read them now. What do these substances have in common? What makes them different? And what predictions can you make about these substances in real life? Okay, so no right or wrong answers. I'm going to create your breakout rooms right now. There's going to be anywhere from 3 to 5 people, which means it's a very small group. So you should be working with each other. Okay, and so unmute yourself. Turn on your camera if you're feeling feisty. Use the chat feature and also use the ask for help button if you need help from me. Okay, so right now what you need to do is you need to make sure that you have the Google Slides open. I just sent the link in the chat. I will send it one more time. The substances are at the top of every group slide, but also on slide number 2, there are bigger images if you need them. Okay, breakout rooms have been opened. Please go ahead and join. Take a look at the questions I send. I'm going to be sending you some thinking questions, and we're going to take about 7-8 minutes on this activity, okay? Go have fun. Go talk to each other. Goodbye. Don't leave. Go to your breakout rooms, okay? All right, welcome back, everybody. Excellent work. Excellent work. We're going to wait for everybody to join, and we're going to look at some of the things that you all thought about these 3 different images, okay? Overall, at least amongst all of the groups overall, you guys did get the main points that I wanted, which is excellent. And so, yeah, we're going to go through these. If you have any questions or anything, feel free to type them in the chat. And we're going to get started here in about 20 seconds once everybody's back. Okay. And if I highlighted something on your screen, that's because I wanted to point it out to the whole class, because we're going to look through all of them here in a bit. Okay. Alrighty. So our 3 substances, which actually I shouldn't be using that word to describe my 3 substances. are going to be in beaker number A, or letter A, we had water. In image number B, letter B, we had water. And in letter C, drum roll please, we had water. Okay, and so as you guys can all tell, these are all water, but there's something going on that makes them different. Okay, and so I just want to go through each group pretty quickly, and I'm going to highlight some stuff that I've read. I read through everything pretty much, but I highlighted some of the main points that I saw. Okay, so on this first side, group number 1, they all have a sequence in which they can start or end in liquid form, which is great. We can predict that when a substance makes contact with surfaces, it will cause it to be filled with moisture. Excellent. A is a solid, B is a liquid, C is a gas. Beautiful. C is H2O at its boiling point. We're going to talk a lot about boiling point in this unit. C has, as a substance, is a lot more dangerous than A or B because we can assume that it has a higher temperature. Okay, very good. Looks like somebody moved one of these, but that's okay. We'll deal with that later. Good. Not everything that I highlighted, that's not only good stuff. I'm just reading through this. One thing down here was highlighted. Did you delete it? What happened? Oh, right here. One prediction I can make about these substances in real life is that if they were all to be left in the exact same environment as B, they would all at some point turn into the B water, which is very good. Okay, that is true. If I had all of these in front of me right now at my desk, eventually at some point they would all end up looking like letter B. Okay, they're all water, which is good. That's one of the most important parts. They are all H2O. Okay, they are all molecules that are one oxygen bonded to 2 hydrogen. So if you were to zoom in, you would just see a bunch of these things. But clearly, something going on is making them different. As you can see here on group number 4, the temperature surrounding these substances determines the form of the substance, which is very good. Okay, couple more groups. They're all made up of water but have different physical appearances. One prediction I can make about these substances is that they all have different temperatures, which is good. They're all water, H2O, dihydrogen monoxide. Thank you for naming it, okay? That is just as important about talking about these things, not just what makes them different, but also what they have in common. Okay, this was very good. The space between the molecules are going to expand or get smaller, making the three stages liquid, ice, and gas. That is very important. We're going to talk about that a little bit today and more on Thursday. Okay, which is excellent. All water, the temperature changes the form that H2O is going to be in. Water being boiled changes it to a gas. Very good. So you guys got the main points. What they have in common, they're all water. What makes them different? They're different phases of matter. We have solid, liquid, and gas, okay? And that's going to be the point of this. Now, obviously, temperature has something to do with this. Heat has something to do with this, but I've already told you that heat and temperature are not the same thing, so we're going to use this idea of the phases of matter, which we know exist at different temperatures, to start to understand what temperature actually is. Okay, so very good job, my friends. I believe that was the last group. Very good. And we're going to have some dear friends help us out to more explain what's going on. Okay, biggest difference, these were all different phases of matter of a substance called water. So we're going to move on over to our dear friends Tim and Moby, and they're going to help us start to zoom in to see what makes these 3 water things totally different from each other. Okay, and a few people have been asking me about how to take notes in chemistry. And so what I'm going to do is in pre-COVID, I would have worksheets like that have guided notes for us to fill out. And I still have these from teaching in the past. So I'm going to start to post these for anybody who wants to use them. They are optional. It's why it doesn't say, but it should say optional notes worksheet. If you want to use this to take notes for what we're doing, this will be to go through today and Thursday, the most important things. You're welcome to use this to fill out the notes, or if you have your own note-taking methods, feel free to do that as well. Whatever works for you, you don't have to submit this, okay? So if you do want to use it, just click File, make a copy, and it'll make you your own personalized copy, and you can go from there. So what we're going to do is we're going to turn it over to Tim and Moby, and they're going to zoom in to the different phases of matter and start to get us to think about what these different things are when we zoom into the atomic scale. Because most of you have probably learned what a solid is, what a liquid is, what a gas is. But in chemistry, we know that if we zoom in, it gets a little bit more complicated. Okay, and so that's what this unit is. We're going to be focusing on the phases of matter, how to change between them, but not unlike the human scale. We're going to zoom in to the atomic scale. Okay, so take it away, Tim and Moby. Let's see what we got. Okay, I played the wrong video in one of my classes, so hopefully this makes up for it. Hopefully this is the right one.
Hey everybody.
Yep.
We'll be starting the movie in a second. Moby's just fixing the camera. Hey, be careful not to beep so close to the camera, Moby. It's pretty expensive. Hey, I think you got it. Try zooming out. Whoa, way too far. Zoom back in. Yeah, good job, I guess. Dear Tim and Moby, what makes a gas or a liquid? From Reynold. Well, gases and liquids are two of the three main states of matter. Right, solid matter is the third main state. Matter is anything that takes up space. It's the material that all the stuff in the universe is made of. All physical matter is composed of tiny particles called atoms. And these atoms behave differently depending on the temperature and pressure of their environment. Hey Moby, can you zoom in on this glass of water? As you can see, water is made up of tiny particles called molecules. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. At room temperature and at normal atmospheric pressure, these molecules form a liquid. The particles within a liquid are packed pretty close together, but they're not arranged in any kind of rigid structure. In fact, they move around and slide past one another pretty regularly. Liquids have a fixed volume, but they don't have a fixed shape. If you put liquid in a glass, it'll take the shape of a glass. And if you put it in a water pistol, well, it'll be shaped like the inside of a water pistol. Hey. Alright, let's say we raise the temperature of the water. If we boil it, it'll change state and become a gas. Zoom in on that steam, Moby. When you increase the temperature of water, you're adding energy to it. The particles get excited. And when that happens, they start moving around a lot faster and get farther and farther away from one another. But the changes in state are only physical. The chemical structure stays the same. Those particles are still regular old water molecules, hydrogen and oxygen. Unlike liquids, gases don't have a fixed volume. They have a tendency to expand, which means they'll fill up any container that you put them in. Yeah, thanks a lot, Moby. Anyway, one more to go. Solids. You're probably already familiar with solid water. We call it ice. Zoom on in here, Moby. When you lower the temperature of water, you're removing energy. As a result, the particles don't move around so much. They're still made of hydrogen and oxygen, but now they're locked into a pretty rigid structure. Solids have a definite shape and a definite volume. Under normal conditions, they look pretty much the same, no matter what container you put them in. Anyway, those are the main states of matter. And
does anybody know there are 2 other states of matter which most people don't talk about? Does anybody know what they are? The other 2 phases of matter? You can either unmute or type in the chat. Hugo said yes. What are they? Sebastian, you typed one correctly. Can you type it to everybody? Jackson, that's correct. Can you type that to everybody? Very good. Plasma is one phase of matter that we don't talk about that much. It's not on the Regents, but it is a phase of matter. They're going to talk about it in a second. And I highly doubt anybody knows this one, but there is a 5th state of matter. Does anybody know what it is? Going once.
So give us a clue.
I can't give you a clue. Going twice. Jarrell, you're on the right track. It's something like as weird as antimatter. Like it's that high level thinking.
Dark
it is
matter.
not antimatter. It is not dark matter, but it is
A black hole.
It's a weird thing. Not a black hole. Black hole is empty. There's nothing there.
The Milky
Okay,
Way.
they're gonna talk to us about it. Let's turn it back over to Tim and Moby. Okay, I don't expect anybody to know this, by the way.
they aren't just for water. All matter, from hydrogen to plutonium, can be a solid, liquid, or gas. There are actually a couple of other states of matter too, but they're not as well known. First, there's plasma, an electrically charged gas. Every star in the sky, including the sun, is made up of plasma. So is lightning, for that matter. And the fluorescent light bulbs in your classroom are actually filled with plasma too. Also, there are colloids, which are mixtures that contain two separate phases of matter. Butter, gelatin, and paint are all colloids. There's even a state called a Bose-Einstein condensate, named after physicists Satyendra Nath Bose and Albert Einstein. That particular state has to be created in a lab since it occurs at close to absolute zero, or about minus 273 degrees Celsius, the coldest possible temperature in the universe. Anyway, that's all we've got for states of matter. You can turn the camera off now, Moby. Hey, I can't see anything.
All right. Thank you, Tim and Moby. So hopefully that got you thinking about the phases of matter, but zooming in to the individual water molecules that we've been learning about in this class, okay? So what we're going to do now is the official definition of phases of matter has to do with something called the kinetic molecular theory of matter, which is basically what this whole unit is talking about. Okay, this unit is called matter and change. So yes, we're looking at solid, liquid, and gas, but also how to change in between those phases. Okay, and so the kinetic molecular theory states that matter will exist in different states depending on particle arrangement and movement. Okay, and those two things, particle arrangement and movement, are going to depend on outside factors, including temperature, but also other things. Okay, so the three main phases of matter are solid, liquid, and gas, which are going to be the ones we saw in our breakout brainstorm. Okay, and as Tim and Moby talked about, there are two other phases of matter, which I typically don't talk about other than right now, but because this year is a little bit different and because people are interested in plasma, it's an interesting topic. We may have like a bonus lesson devoted to these weird phases of matter towards the end, okay? They're going to be plasma, which plasma, the phase of matter plasma is basically gas particles but with an electric charge. And so something that you may have seen before that shows plasma are these like cool like 90s light things. They're called plasma balls. And basically you have a vacuum with just like a little bit of air in here, a specific air, and you put electricity through it and those gas particles get a charge and so they light up. Okay, and so this is going to be the same thing in fluorescent light bulbs. It's going to be what happens on the sun to produce light. Okay, and then the fifth stage of matter, which Sanu got really close to in the chat, is called a Bose-Einstein condensate. And you don't need to know anything about these. Most people don't know anything about them other than like physicists and chemists. But basically, you can think of them as like super duper solids. Okay, Bose-Einstein condensates are going to be like super cold solids. They said they're going to exist at temperatures close to absolute zero, which is the coldest anything can be, which we'll learn about later in this unit. Okay. Colloids we'll actually talk about in our next unit because they're actually mixtures of phases of matter. They talked about jello and butter. Those are going to be like thoroughly mixed solids and liquids in the same thing. Okay, so it is a mixture. We're talking pure phases of matter here. Okay, so the main ones we're going to focus on are solid, liquid, and gas. And as most of you put in your brainstorm, one thing that's going to determine whether or not a substance is a solid, liquid, or gas is our dear friend temperature. Okay, now I have told you that temperature does not measure heat. Okay, it is related to heat, of course, but it does not actually tell you how hot or how cold something is. Okay, somebody got close in the brainstorm. I don't remember what it is, but I'm about to reveal to you the truth. Okay, we're not doing fake news here. We're only speaking the truth. And so the question is, what is temperature? Drum roll, please. I'm assuming you're all drum rolling. Temperature is officially defined as, and get used to this because I'll be asking you this probably every day for the rest of the unit, the measure of average kinetic energy. Okay, wow, boom, bang. Notice how nothing in here says hot or cold or warm even. But it is the measure of average kinetic energy. It's not energy itself, it's how we measure it. That's why it always comes with a number and a unit. It says average because remember that in this little cup of water, there are millions, bajillions, and everything of teeny tiny water molecules. So, of course, there are going to be some that have a little bit more kinetic energy than others. Ooh, Naomi's onto something. So, when you put a thermometer in here, it's going to measure the average kinetic energy, which, if you look what Naomi wrote, kinetic energy should be something you're familiar with. Kinetic energy is the energy associated with movement. And so if we're talking about average kinetic energy of particles, exactly what Naomi said, the other way you can describe this is how fast particles are moving. So if you say something has a high temperature, yes, it feels hot. But what it actually is going into is you are going to have particles that are moving very, very fast. How that exactly, Marlon, how that translates to us feeling something as heat, we'll learn about later on, okay? Maybe you might be able to start thinking about it now. But for right now, we're going to stop with this idea of temperature, the measure of average kinetic energy, in other words, how fast particles are moving. High temperature means they're moving very quickly. Low temperature means they're moving slowly. What it does not mean is that they have stopped moving, because particles never stop moving. If they stopped, some weird like Einstein stuff would go down, and you'll learn about that like in theoretical physics in grad school, okay? But we're going to stop here. Temperature is the measure of average kinetic energy. I bet you could take a guess as to what your warm-up question will be on Thursday, but we're going to stop now, okay? That was going to be our ultimate thing. What is the definition of temperature? Asynchronous work will be posted tomorrow morning. To be completely transparent, I don't know what it's going to be yet because you guys are in a weird situation where your async day is before the lesson. So I'm going to figure something out and we'll do the Paradex stuff on Thursday, okay? If you have any questions, feel free to stick around. There were a few questions in the chat, so I'll answer them here in just a second. But if you gotta go, it is 2:16. I hope you all had a great school day, and I will see you on Thursday, okay? Goodbye.